restrictions or with conditions. It's if we have the same elements in a set. In that case, what should we do? For example, in here we have A, B, C, three different elements. So its permutation is easy. It's 3 factorial, or permutation of 3 from 3. But if we have A, B, C, D, in here we have two same A's. In this case, the permutation of them is not permutation of 5 from 5 because in here we have two same A's. If we give them some indications, some index like A1 and A2, in this case these two will be different. For example, in here A1 B, A2 C, D, and A2 B, A1 C, D, they are different. But if they don't have any index like 1 and 2, in this case they will be same. So for these types of permutations, what should we do? How can we calculate it? We can calculate it using this method. If we have n elements in a set A, and n1 is the number of one kind of elements, n2 is the number of second kind, n3 is the number of third kind, and so on, that such that n1 plus n2 plus n3 plus n4 plus nr is equal to n. So in this case, the distinguishable, or the permutation that we can distinguish, or we can differentiate two different types of or two different types of permutation, or two different permutation, will be n factorial, the total number of elements in a set, over n1 factorial times n2 factorial times n3 factorial times n4 factorial times n r minus 1 factorial times n r factorial. For example, let me show it in an example, you will understand it better. How many different permutations are there from the digits of 5, 7, 1, 1? As you see in here, we have 1, 1, or two elements same, but we have only 1, 5, we have only 1, 7, but we have two ones. So the total number is 4. So what's the permutation of them? The permutation of them is 4 factorial, the total number, over how many 5s do we have? 1 5. So 1 factorial times how many 7 do we have? 1 factorial times how many 1s do we have? 2. So times 2 factorial. And it's equal to 4 factorial, 4 times 3 times 2 factorial over, over 1 factorial is 1 times 1 factorial is 1 times 2 factorial. 2 factorial cancelled by 2 factorial, and it's equal to 12. It means how many permutations of digits do we have for 5711 or 5711? We have 12 different permutations. Next example, in a kitchen there are 3 identical porcelain dishes, 2 identical metal dishes, and 4 identical glass dishes. In how many different ways we can arrange them, or we can line them up? Again, what's the total number of dishes? Identical means same. 3 same porcelain dishes, 3 plus 2 same metal dishes, 5, and 4 same glass dishes, so 9. The total number of them is, the total number of dishes are 3 plus 2 plus 4 factorial over how many same porcelain dishes are there? 3, so 3 factorial times metal dishes, 2 factorial times the same glass dishes are 4, so 4 factorial, and it's equal to 9 factorial over 3 factorial times 2 factorial times 4 factorial, and it's equal to, if we calculate them, we will get 1260. Will be the different ways to pile them up. Another example, a teacher has 5 identical math books, 5 same math books, 3 same biology books, 4 same physics books. And how many different ways can the teacher arrange her or his books on a shelf if books about the same subject must be together. In here we use permutation with grouped elements and also permutation with identical elements or same elements. As it says that it's said that the books with the same subject must be side by side. So we accept math books as one group and accept physics books as one group and biology books as one group. Factorial times. Now the permutation between math books is also important. So the total number of math books is 5 factorial over, and what's the number of identical or same elements in here is also 5 factorial times or 5. And also the permutation between biology books is the same as for math. There are total number of 3 books for biology, and what's the number of identical or same elements? It's also 3, so 3 factorial over 3 factorial times. The number of physics books are also, the total number is 4 factorial or 4. So the arrangement permutation is 4 factorial over same book, same physics books are also 4, so over 4 factorial, and it's equal to 5 factorial cancelled by 5 factorial, 3 factorial, sorry, cancelled by 3 factorial, and 4 factorial cancelled by 4 factorial. So 1 plus 1 plus 1 is 3 factorial, and it's equal to 6. So how many different arrangement or permutation do we have for these books as it's written in the example? There are 6 different permutation for these. Another example, how many three-letter words can be found from the letters in the word narin, N-A-R-I-N, if each word must contain both N's? It means from 3 letters, 2 of them must be N, the other one can be A or R or I. So in here, as the total number is 3, so again the permutation is 3 factorial because the total number is 3 over how many identical or same elements are there? There are 2 n's, so 2 factorial times the other one will be 1 because we don't have any other choice. But this permutation, I mean 3 factorial over 2 factorial times 1 factorial, is only for one of the other 3 words, one of for A or R or I. So we have 3 different words in here. So let's multiply it by 3 also. So it's equal to, and 3 factorial is 3 times 2 factorial over 2 factorial times 1 factorial is 2 factorial times 3. 2 factorial cancelled by 2 factorial, and it's equal to 3 times 3, 9. It means how many permutations do we have for this condition or this restriction that it must contain both n's and one of the other words will be A, R or I. So there are 9 permutations for them. Next example, every day Nazar walks from his house to school. Nazar's neighborhood, his streets laid out in a grade system as shown by the grade line below. In here it's shown. If Nazar is only allowed to walk eastward to right side and northward upside along the streets, in how many different ways can he walk to school? As you see in here, he can walk only eastward and northward. So this street, this street, this street, this street, or any of these streets are all same for him to walk to eastward, or maybe to north side or upside. All of the streets are same for him. But how can we? How can Nazar walks, or how many different ways are there that Nazar walks from his house to school? As you see in here, we have 3 north streets. One of them is this, and this one. All of them are identical or same. And we have 5 different upside streets. 1, 2, 3, 4, and 5. 3 streets walks to or goes to east side, and 5 streets goes to north side or upside. So and all of these streets are identical or same for Nazar. He can go from first, second, third, fourth, or fifth one, or to eastward. He can go from first or second or third one. Any of them, it doesn't matter for him. But the total number of streets in here, 5 plus 3, is the total number of streets which are identical over how many streets are there identical to eastward. There are 3, so 3 factorial. And how many streets are to north side? There are identical streets, I mean 5. So the total number of the ways, different ways that Nazar can walk to school from his house is 8 factorial over, I'm sorry, it's 8 factorial over 3 factorial times 5 factorial, or we can also write 8 factorial as 8 times 1 times 6 times 5 factorial over 3 factorial times 5 factorial. 5 factorial, 5 factorial cancel, and 3 factorial is equal to 6. So 8 times 5 is 56. So how many different ways are there? 56 different ways are there that Nazar can walk from his house to school. Check yourself. 9 is your homework for this subject. And if you solve these examples, and if you have any problem, you can contact with our school WhatsApp number. I will respond your questions. Thank you.